How Nvidia became the AI king. Nvidia was not originally an artificial intelligence company. It was a graphics card company. For decades, Nvidia was known primarily for powering video games, high-performance GPUs, real-time rendering, gaming enthusiasts. Nothing about that positioning suggested dominance over artificial intelligence. Yet today, Nvidia sits at the center of the global AI infrastructure stack. Data centers depend on it. AI labs depend on it. Cloud providers depend on it. To understand how Nvidia became the AI king, you have to understand three structural forces: parallel processing, software ecosystems, and timing. Nvidia's core product is the GPU, or Graphics Processing Unit. Unlike a traditional CPU, which handles tasks sequentially, a GPU is built to perform thousands of operations in parallel. This design was originally meant for rendering graphics. Rendering images requires processing millions of pixels at the same time. Parallel architecture made that efficient. But that same parallel architecture turned out to be ideal for something else: machine learning. Training neural networks requires performing massive numbers of mathematical operations simultaneously. Matrix multiplications, tensor calculations, floating point calculations. The same structure that renders video game graphics can accelerate AI training. This was not accidental luck, it was architectural alignment. Nvidia's early bet on parallel computing created a foundation that later became indispensable to AI. But hardware alone is not enough to dominate an industry. The second structural advantage Nvidia built was software. In 2006, Nvidia released CUDA. CUDA allowed developers to program Nvidia GPUs for general-purpose computing, not just graphics. That decision was strategic. Instead of limiting GPUs to gaming, Nvidia opened them to scientific computing, data analysis, and research. Over time, researchers began using CUDA to accelerate machine learning workloads. Once developers build around a platform, switching becomes costly. Code bases grow, tools integrate, libraries form, communities expand. CUDA created an ecosystem lock-in. By the time artificial intelligence exploded in mainstream awareness, much of the research community was already building on Nvidia infrastructure. Competitors could build comparable hardware, but they did not have the same software integration. Hardware can be replicated. Ecosystems are harder to displace. The third force was timing. Deep learning breakthroughs accelerated in the early 2000s. Image recognition models, speech processing, natural language systems. Training these models required enormous compute power. Traditional CPUs were too slow. GPUs were dramatically faster. Cloud providers began purchasing Nvidia hardware at scale. Data centers filled with Nvidia accelerators. As demand increased, Nvidia reinvested aggressively into specialized AI chips. The company did not stand still. It evolved its GPU architecture specifically for AI workloads. Tensor cores, optimized memory bandwidth, high-speed interconnects. Each generation became more specialized. This is where scale compounds. When cloud providers like Amazon, Microsoft, and Google build their AI infrastructure around Nvidia, the switching cost increases dramatically. Entire data centers are optimized for Nvidia hardware. Software frameworks are tuned for Nvidia acceleration. Developers write models expecting Nvidia performance characteristics. This creates dependency. Dependency creates pricing power. Pricing power creates margin expansion. Nvidia's gross margins reflect this dynamic. When demand for AI accelerators surged, Nvidia's data center revenue expanded rapidly. Margins increased because supply was constrained and demand was explosive. But Nvidia's dominance is not purely technical, it is also strategic. Instead of selling only hardware, Nvidia positioned itself as a full-stack AI infrastructure provider. Hardware, software, development kits, enterprise solutions. The company integrates tightly with AI frameworks like PyTorch and TensorFlow. It invests in research partnerships. It supports academic communities. This reinforces its central role in the ecosystem. When artificial intelligence became a strategic priority for governments and corporations, Nvidia was already embedded. That embedded position is difficult to challenge. Even large competitors face structural disadvantages. Building an alternative chip is possible. Building an alternative ecosystem is much harder. Because ecosystem strength is not just about performance, it is about familiarity. Developers prefer tools they already understand. Enterprises prefer systems that already integrate. Switching creates operational risk. Operational risk slows adoption. This inertia protects Nvidia. However, dominance invites pressure. Competitors like AMD continue to develop AI accelerators. Cloud providers experiment with custom chips. Governments explore domestic semiconductor strategies. The long-term durability of Nvidia's dominance depends on its ability to innovate faster than alternatives mature. But Nvidia benefits from compounding scale. Higher demand funds, higher research investment. Higher research investment improves performance. Improved performance attracts more customers. The cycle reinforces itself. There is also a geopolitical dimension. Advanced AI chips are strategically important. Export restrictions and trade policy affect supply chains. Nvidia must navigate global regulatory complexity. This adds another layer of structural risk, but it also reinforces its importance. Few companies operate at the center of both technological innovation and geopolitical relevance. Nvidia does. From a systems perspective, Nvidia's rise was not a sudden breakthrough. It was the convergence of architecture, ecosystem, and timing. Parallel processing provided technical advantage. CUDA created developer lock-in. Deep learning demand created explosive growth. Cloud infrastructure embedded the hardware at scale. Once embedded, switching costs multiplied. That is how Nvidia became the backbone of modern AI computation. It did not pivot overnight. It built a foundation years before the AI wave crested. When demand arrived, the infrastructure was ready. This is often how dominance forms. Preparation meets structural shift. Companies rarely become central to new industries by improvising. They become central by aligning early architecture with future demand. Nvidia aligned its architecture with parallel computing long before AI was mainstream. It invested in software ecosystems long before developers fully exploited them. When artificial intelligence required enormous compute power, Nvidia's systems were already in place. The result is not accidental. It is structural. Nvidia is not merely selling chips. It is selling acceleration infrastructure. Acceleration infrastructure underpins artificial intelligence, and artificial intelligence underpins the next generation of digital systems. That alignment explains Nvidia's central position. It also explains why the company commands extraordinary attention from investors, competitors, and governments alike. Nvidia became the AI king not by chasing headlines, but by building systems that were ready when the world needed them.